Yeah, good day guys. So today we'll be treating indices and logarithms. So let's quickly go through it. So here we have some basic rules of indices. The first one we have here is x raised by a times x raised by b is equal to x raised by a plus b. So this simply means that when we have a figure of a particular base multiplying another figure of the same base, we can easily add up their powers as 1. Let's say we have 2 and then we have 2 raised by 2 as in 4 multiplying each other. So we can easily say 2 raised by 1 times 2 raised by 2 is equal to 2 raised by 1 plus 3 since they have the same base. So that is what this simply means. This is very straightforward. So it says that where x is the base, a and b are powers. So because x and the two x are the same, they have the same base, we just had to add up their powers. So this is true for all values of x. For example, 3 raised by 4 times 3 raised by 7. Because we have 3 as their base, we can add up their powers to become 1. That will give me 4 plus 7. 4 plus 7 is what? That should be 11. So my answer becomes 3 raised by 11. So simplify x, 8 raised by 4 times 8 raised by minus 3. This is also very straightforward. They are multiplying each other. They have the same base. Add up their powers. So that will give me what? 4 plus minus 3. And 4 plus minus 3 is what? When you multiply, when plus and minus multiply each other, it turns out to be minus. So here we'll be having it as 4 minus 3 eventually. So, and then we have it as 8 raised by 1, which is 8. As simple as that. So the second rule, it says when we have something like x raised by a divided by x raised by b, we can rewrite it as x raised by a minus b. When they have the same base and they have different powers or the same powers, as far as their base are the same and then they are dividing each other, you can easily subtract their powers from each other. You subtract the latter from the first one. Let's go through another example to understand this better. Simplify 4 raised by 20 divided by 4 raised by 8. So here we have 4 as the base. So we can easily subtract 8 from 20 as in 20 minus 8 to give us a single value. So I'll have 4 raised by 20 minus 8 and that should give me 4 raised by 12. So that's as simple as that. So let me check out another example. It says here 8 raised by 20 divided by 8 raised by minus 8. Okay, how do we go about this? The same method. They have the same base and they are dividing each other. Subtract their powers. That would give me 20 minus, but the second power of x has a negative already, so we can just put that into brackets and call it 20 minus, then open your brackets, minus 8 as we have it here. So minus times minus would give me plus. So I have 20 plus 8. So that gives me 8 raised by 20 plus 8, which is 28. As less that. So let's go through another rule. This is x raised by a, open your bracket, put p into it and then close your bracket, is equal to x raised by ab. This simply means when you have their powers like this, you can easily multiply them together and make them 1. You can fuse them together as 1. Let's say we have x raised by 2, open your bracket 3 and close your bracket. We can call this x raised by 2 times 3, which is x raised by 6. For example, we have 8 raised by 2, open your bracket, put 8 into it and close your bracket. We can rewrite this as 2 times 8 as in their power. So we'll have 8 raised by 2 times 8, which is 8 raised by 16. These as well, simplify 8 raised by 2 over 3. Open your brackets 9, then close your brackets. In this situation, we can multiply the fraction by the whole number, the fractional power by the whole number. That is also a power. So we have 2 over 3 times 9. 2 over 3 times 9 means 18 over 3 because 2 times 9 is 18 over 3. 18 divided by 3, by your calculator, you should have 6. So our answer gives 8 raised by 6. As easy as that. And then in the fourth rule, we have x raised by 0 equals 1. As far as anything is to power 0, we always have 1 except for 0 itself. So any number raised per 0 is always 1 aside 0. So if I say 1000 raised per 0, the answer is 1. 1 million raised per 0, my answer is still 1. Anything raised per 0 is always 1. Negative raised per 0 is 1 except 0. So that's that about that. We have 44 raised per 0 equals 1. 1000 raised per 0 equals 1 as well. So here in my fifth rule, it says x raised per a times y raised per a equals, open your bracket, xy, close your bracket, a as in raised per a. So in this situation, the difference between this and the first rule is the fact that here the powers are the same, not the base. Their bases are different, but the powers are the same. So when we have their powers being the same, you can easily multiply their base and pick one of their powers, and then you are done. Let's say we have 2 raised per 2 times 3 raised per 2. Now we have 2 as their powers. We can easily multiply their base 2 times 3 to give you 6 raised per 2. So that's what this is all about. So let's check out some examples. Here we have it as simplified 22 raised per 3 times 4 raised per 3. So from x raised per a times y raised per a, which will give xy raised per a, we have our power a has 3 and 3. Wow, so we can put this into, you can put this rule into this question and get our required result. So we multiply 22 by 4. 20 times 4 is 88. Then bring in your 3 as it is here. So we have 88 raised per 3 as our answer. So in the fifth rule also, here is all about the division. If you have x raised per a divided by y raised per a, as in their powers are equal, you can easily divide their base. You can divide the latter base, the first base by the latter base by the second base. That will be x over y. Then open your brackets, raised per a. As simple as that. So let's try out some examples. This is simplified 33 raised per 9 divided by 11 raised per 9. So here we have our powers as 9. So what do we do to this? We just divide their base by each other. So that will be 33 divided by 11. That's 3 over 11. 11 times 3 will give me 33. So 33 over 11 will give me 3. So that will be 3 over 9. Okay, so the sixth one, we have nth root of x is equal to x raised per 1 over n. So in a situation like this, it's telling us that when we see something like this, any kind of indices like this, nth root of x, we can easily write it as x raised per 1 over n. So if I say fourth root of x, I can write it as x raised per 1 over 4. Third root of x, I can write it as x raised per 1 over 3. And then likewise, if we have nth root of x raised per a, we can rewrite it as x raised per 1 over n times a, which is x raised per a over n. So it's easy as that. Maybe when we try some examples, we understand better. So the first one we have here is that if we define the third root of 8, now we write our third root as 8 raised per 1 over 3. That's very cool. But then how do we solve this? But remember that we can easily make our 8 into a power of 2 raised to power something should give me 8, right? So if I multiply 2 by 2 by 2, that would give me 8. So that would be, I'm multiplying 2 3 times, that would be 2 raised per 3. So 2 raised per 3 is giving me 8. So I can write my 8 as 2 raised per 3. So that's when I'm writing it, I have 2 raised per 3 times 1 over 3 that was already there. So 3 and 1 over 3 will cancel out, as in 3 divided by 3 will give me 1. So I'll have 2 raised power 1, which is equal to 2. So you can see the application here, which is equal to 2. So note that nth root x is not the same thing as n root x. Please take note. N root x is a short form, is in short form, while the other one is an nth root. Please note the difference. So here in this question, it says find the second root of 25. Then the second root is the same thing as the square root. Square is the second root. So we have it as 5 raised to power 2. And 5 raised to power 2 is 25. 5 squared is 25. So bring in your 1 over 2 as our 6th rule says. So they will cancel out. We should have 5 raised to power 1, which is 5 as our answer. Now, but for 2 roots 25, look at what we have. We have 2 times 5 equals 10 because root 25 itself is 5. So 2 root 25 means 2 times root 25. I'm trying to tell you to note the difference between nth root of x and n root x. N root x means n times root x. N is multiplying root x. Nth root of x, it is the reciprocal power that we are having here. As simple as that. So in our next video, we'll be treating logarithms and probably the continuation of indices. So thanks for watching, guys. Please, if you enjoyed the video,